Hey guys, so in our last notes, we talked about symmetry and how that is um, point or figures being able to be rotated or folded, and it still looks the same. Well, now we're going to talk about taking those figures that look the same and either making them larger or smaller. And so, a dilation is a transformation that we're changing. The position of a figure in the coordinate plane, and we have our pre-image, which is our starting image, and our image, which is our ending image. And we can tell the difference between our pre-image and our ending image, or just our image, because we mark it with these prime tick marks up here. So this is our starting image, our pre-image, and if we dilate this one, we're going to make it into this second image, or we're just going to call it our image, and we're going to know the difference because we're going to be using that prime mark. So a dilation is a transformation in which the image is a different size than the pre-image. We're either going to make it bigger, and that's an enlargement, or a reduction, and that is making it smaller. To dilate a figure, we take the coordinates of that figure that we're given, our x and our y, and then we multiply them by the scale factor. And sometimes the scale factor is given to us, and sometimes we have to find it out. So on this one, when we're looking at our reductions, our scale factor is going to be any number in between 0 and 1. So A here is representing our scale factor, and if we're making it smaller, we're going to multiply by a fraction or a decimal. If we're going to make it larger, we multiply our coordinate by any number greater than 1. So if we have a figure and we're going to dilate it by a scale factor of 1, well, 1 times anything is just itself. So our image would be the same size as our pre-image. Let's look at this. So we are going to dilate this triangle. We're going to use the original coordinates for this blue triangle. So our pre-image coordinates are going to go here, and we're going to dilate this with a scale factor of 2 in this column and a scale factor of 1/2 in this column, and we're just going to fill out our chart. So our original coordinates for this triangle, we have R, N, and M, and these are our original coordinates, and they're already plotted right here in blue. Now, to dilate these points by 2, or to a scale factor of 2, we multiply each point by 2, or each coordinate of each point. So 2 times 2 and 3 times 2, 4. This one is 4 times 2 and 1 times 2. And this is -1 times 2 and -3 times 2. And when we go here, these are our new coordinates of R prime, N prime, and M prime, because we use that prime because that's our ending image. And this red triangle here is our plotted points that we came up with here and drawn the triangle. So this red triangle is twice the size of the little blue triangle. So now we're going to use our same pre-image points, and we're going to dilate this triangle to a scale factor of 1/2. So now on here, we're going to multiply each coordinate by 0.5. So we do 2 times 0.5, 3 times 0.5, 4 times 0.5, and 1 times 0.5. And on M, it's -1 times 0.5 and -3 times 0.5. And here in this purple, right here in this column, we have our new coordinates for our triangle that has a scale factor of 1/2. And over here on the graph, you can see that this little purple triangle is 1/2 the size of our blue triangle. So sometimes you may be asked to find the scale factor of a pre-image and its dilated image. And we're going to be able to do that by using ratios to find the scale factor. So we're going to choose which ratio works with the problem that we have. And with any ratio, we're going to reduce it as much as possible. So it's going to look like a fraction. So to find the scale factor, we have these three options. We can take the image x coordinate over the original x coordinate. We can take the image, our ending figure y coordinate over the original y coordinate. Or we can take the image side length over the original side length. And so we're going to use the side length on things when they do not give us the coordinates, but give us the measure of our sides. So let's look at that here. We have these two rectangles here. We have green and purple, and we need to figure out which one is our original, excuse me, and which one is our ending image. Well, we can tell that because the little green rectangle, its corners points are marked with the prime symbol. So we have A prime, B prime, C prime, and D prime. So we know that this one is going to be our ending image. And if our purple one is our starting point and our green one is our ending point, we obviously went from bigger to smaller. So this is going to be a reduction. We can tell this, so let's prove it. So on here, we're not given the coordinates of our points for this figure, but we're given the side lengths. So let's look at the side lengths that are marked 12 and 9. Well, to solve here, we take our image side length or our ending side length, and we put that over our original side length. So our image side length here is 9 millimeters, and our original was 12 millimeters. And so we get a fraction or a ratio of 9 over 12. Well, we can reduce that to 3/4. Well, 3/4 is not a number bigger than 1. So we know that this is a reduction by 3/4. Pretty simple. Also, I want you to note that we could have used 4.5 and 6, and we would have gotten the same thing, just 9 and 12 are easier to work with. So on this example, we have two figures, and we need to find the scale factor in the figure below. Well, this one, it gives us our points. We're going to work with this point Q here. And our first thing we need to determine is which one is our original, our pre-image, and which one is our ending, our image. So, well, this one, our blue figure here, is marked with our prime apostrophe, so we know that this is our ending image. So if we went from this red image to this blue image, we can tell that it's an enlargement. So let's see what our scale factor is. So we have our points here, our original point, 1,4. Then we have our ending point of 2,8. So now we have our points, we have our coordinates. Now we're going to use one of these, our ratios. Remember, we can use our x coordinates or our y coordinates. On here, we're going to use the y coordinate just to try it out. So we put our image y coordinate, so our ending y coordinate, which is 8, over our original y coordinate, which is right here, it's 4. And 8 over 4 is, we can simplify that to 2. So 2 is a number bigger than 1. So we know that this is going to be an enlargement, and we just proved it. So on here, we're going from our, we're finding if our scale factors create a reduction or an enlargement. Well, from our number 1, it's an enlargement because we are going from 2 to 6, it's getting bigger. On 2, they're kind of trying to trip you up because they switched it from original to new and went back and forth. So our original is 15, and we went to 3, so it's going to be a reduction. 3 is our original image here is this 8,12 because this second image or point has that prime mark. We go from 8 to 2, and so that gets smaller, so we know that's a reduction. We got to find our original image point on number 4 here, and it's going to be this point here of R as 3, -4.5 because it does not have the little tick mark, and this one does. This is R prime. So if we start at R and go to R prime, we have 3 to go to 2. Does it get bigger or smaller? It gets smaller, so it's a reduction. So just some fun facts about dilation. Remember that the pre-image is similar to its dilated image, and a dilation of 1 will produce an image that is the same size as the pre-image. Dilations are the only transformation that produces an image that is a different size than the pre-image. And a little real life connection here for you. If you've ever gone to the eye doctor and they've put those little drops in your eyes and they say they're going to dilate your eyes, well, they're really putting those drops in your eyes to make your pupils get bigger. So our last activities on these notes, here is a your turn activity. And we're just going to fill in this chart by the scale factor. These are our pre-image points. These are our scale factors. At this one, we multiply each of these coordinates by 2. This factor, we might multiply each x and y coordinate by 0.5. On this one, we multiply each x and y coordinate by 1. And on this one, we multiply each x and y coordinate by 5. And we fill that in. Hopefully you can pause here and check yours to make sure that you filled it in like I have filled mine in. Next, we will be using the tiles on slide 16 to fill in the answers for each of these dilations. So 1/2 dilated by a scale factor of 4 gives us 4,8. -6, -3 dilated by 1/3 brings us to -2, -1. 0, -8 dilated by a scale factor of 1 gets us to 0, -8. 10, -2 dilated by 1/2 gets us to 5, -1. 7, -6 dilated by a scale factor of 4 gets us 28, -24. -1, 0 dilated by 8 brings us to -8, 0. And -4, -9 dilated by 0.5 brings us to -2, -4.5. And our last one is 3, 8 dilated by a scale factor of 2, and that brings us to 6, 16. So hopefully you have these same tiles in the right places. If not, go change it. Remember, we need all 12, 14, and 15 completed on these notes, guys. If you have any questions, please let me know.